Hi, so what I'll present today is mostly about the project we had this summer, ICAT-funded project about connecting Virginia learning communities. And the idea is to kind of bring together various uh, skills, expertises. So the team included uh, also Jim, who is in Tinkerbit Lab up in Northern Virginia, Debbie, University Libraries there, and also two students who helped with implementation. So what is the goal? And what we are trying to do, and of course it's a process, it is not the something that you can do overnight or during summer, is to look at how we can develop an IoT-enabled extended reality infrastructure and related tool. And in this particular focus was to support library activities and also to provide some kind of framework to connect learning communities throughout the Commonwealth, because we are seeing a lot of needs and a lot of issues when it comes to distance learning using Zoom, etc. Just to give you an example, we talked to some high school teachers, and there are, what was that, September, October, 30% of students never actually joined Zoom session for their classes. So there is a really lot of problem, and there is, I think, Loudoun County students submitted a petition, like 11,000 of them, saying that they feel that the current technology for learning is simply not there. So what I'll try to do is to kind of talk from my perspective why that might be the case, and also see how we can actually go about changing that, or at least providing some affordances for better distance education. So in this particular work, we are focusing on teachers. In other words, it's not so much about student side, although it may sound kind of, what do you mean? You are not focused on student? No, I think it's really the problem is how to help teachers, enable teachers to effectively use those new technology, and also to provide content and adapt their content for uh, distance learning in combination with XR and all those nice things that come. So first, the next thing is that if you think about extended reality and all the recent, things, technologies that are there are a lot of opportunities there because cost is down, availability of different type of devices is increased, and the industry, and I'm going to provide some numbers at the end, the education industry, XR education industry is growing significantly. So they are all trying to somehow enhance student learning to increase knowledge retention for students. So before we proceed, just to kind of to provide foundation and make sure that we are use the same terminology, when we talk about extended reality, is actually an umbrella term that covers all kinds of technologies that can merge physical and virtual worlds. So some of the better known terms or acronyms: augmented reality or AR, virtual reality VR, and mixed reality MR. And also there are some other technology or for example, augmented virtuality, which is these days not as much in use. But if you ever use Oculus Quest, and when you get outside the boundary and it gives you the picture of the real world, then you actually have that augmented reality, augmented virtual environment with visual feed from the real world. So one of the common characteristics of these devices and systems is they're using spatial mapping to place virtual objects. In order to be effective and efficient in terms of mapping and merging real and virtual world, you somehow need to establish a relationship between their respective coordinate system. And through that, you can also support embodied interaction. One of the biggest problems that I find with Zoom, especially when it comes to, let's say, science labs, vocational training, things like that, there are no experiential learning opportunities to learn new skills or to train for new skills, because using Zoom or using your, let's say, traditional VR on the screen, well, let's call it VR on the screen, or some of the other even games, is just not quite there yet. So what can we do? Well, what we can do, we can try to integrate all different technologies, different approaches, and put them together in a system that can hopefully provide desired effect and really provide affordances for distance learning. So in addition to extended reality that I already mentioned, we certainly have let's say at the uh, lower level, if you can call it that way, the physical layer, we think about Internet of Things. In other words, all those network capabilities, ecology of computing smart devices using Internet. What it means is that now we can really talk also about smart immersive environments. We can talk about uh, putting that Oculus Quest and being in virtual environment. However, that Oculus Quest in placed in smart environments, and that smart environments can augment information provided to users. So therefore, we can talk about smart immersive environment. In order for that to work, and also to provide some guidance, to provide let's say some conversational agents, to provide uh, additional functionality, we also need to take into account artificial intelligence and related techniques and tools. So now we are coming to extended reality and K through 12. And here we are talking about mostly about engagement, how we can actually use extended reality to boost student engagement. What are some value-added enhancements we would like students to explore, create, problem solve, and access their work again? While we are still using extended reality, that we can connect learning to real world. And so learning about the world outside the classroom without leaving it, or learning without leaving at their home or wherever they are taking that classroom. So in K-12 case, we have, again, opportunities, but also challenges, how we can help educators to actually achieve that and support students to learn that way. Similar approaches were taken in higher education, and there were studies conducted, and there are some empirical evidence that XR actually does have efficacy in terms of using it as a technology for teaching and learning. However, again, the problem is the lack of educational resources, because what then we can do, and what are some of the methodologies being used. Let's have students learn about XR and how to actually build XR content and application, and then use that engagement to help build and develop content, curriculum content for various subjects. So let's look a little bit about collaboration. So obviously we are using Zoom, so we know what Zoom is, but there are some other tools that we can use for collaboration that are XR-like or XR-based. So first of all, Mozilla Hub. So when in spring we had that COVID situation developed, IEEE Virtual Reality Conference use Mozilla Hub. So again, what we have here, we have virtual environment simulating or mimicking, I should say, the physical environment of a classroom, and providing place to navigate. And same thing happens with some other programs such as Virbela. So that's a platform that is being used for ISMER, International Symposium on Mixed and Augmented Reality, which is taking place next week. So slightly different environment, but again, you have that big campus. In that campus, you can go from room to room, from classroom, and again, what you're going to end up, you're going to end up in similar situation like you have seen for Mozilla Hub. And I would say, wow, this is great. We can create some new opportunities. That should certainly be very exciting. But then if you are doing this for some time, you should probably remember Second Life. And if you look at the Second Life or high days of Second Life, something in, again, another online collaborative virtual environment, that was, I think, 2010, 2012. Again, the same thing, the same ideas. You have education, you have that quote-unquote island corresponding to that Virbela campus, and you can go in various rooms, you can read on the information, poster, etc. But I just, before this presentation, went to some old educational site, or I should say locations or islands, and half of them are actually gone. When I map and teleport to that, I was basically sinking the ocean. I don't know how much you're familiar with the Second Life, but what you have a collection of islands. So therefore, if you have that, you buy yourself an island, on that island you build virtual environment. So all those educational islands, so to speak, where they just disappeared, and which gives you some idea that obviously it is not so much about having nice graphic, about ability to connect and create online distributed virtual world. There should be something more. So what are some of the obstacles that we have identified? Well, first of all, problem is retention. Online in itself has very high dropout rate. Just if you look at some of the online courses websites, they have that, like, I don't know, 10% retention, which is very low. And then there is that sense of discontent because we cannot do everything in real world. And that leads us again to that limited support for experiential learning and learning in laboratory and practical settings. If you're using Zoom, it doesn't really matter, whether someone remotely is doing some experiments. You would like to be able to get closer to explore that. And so therefore, how we can actually use XR to help support those science labs, vocational training certificates, and so on. So I think the main problem is interactions. And I mentioned at the beginning embodied interactions, because doing that with mouse, and even if you're having some good VR headset, it is still not quite there. So the example that I always like to use actually has to do with my house. So these are the light switches in my house. I always joke that that's one of the reasons I bought that house, because I wanted to figure out those lights. And after, well over a decade in that house, I'm still not certain for at least half of those switches what they're doing. I know for 6 that I use frequently, and then whenever I need to turn on light in my driveway, which I do quite seldom, it takes me like 3 or 4 trials. I have to run back and forth to figure out whether the lights are on in my driveway. So again, so this is the real world example, but you can also imagine that if you go to let's say if you go to conference in a hotel and there is that big conference hall or your room where you present, first question is, if you come first and everything is dark, where are those lights? How we can actually get that? So there is that problem with interactions, is that how you can actually learn them inefficiently. And one way to deal with that is to provide embodied interaction. So this is an early experiment, maybe 3 or 4 years ago. I think it was published at 3D UI conference, is how you can actually use whole body to control lights. With new interaction comes new technology. So now the light is not a single light bulb hanging from the floor. Rather, it is a whole, let's say, light surface, although in this particular case, it was perimeter of that rectangular area. By the way, this is Future House, Virginia Tech, what is the phrase? Virginia Tech award-winning solar house. What the idea is how we can actually do painting with light, how we can develop certain gestures that will allow us to naturally interact. So obviously point to the area we want to light, using our second hand to define the color space is then something that can, and again, we develop system for what if we have multiple users, who takes precedence, several users in parallel painting their particular area of light. So again, you can really think about a new embodied interaction, but your body becomes a user interface. At the very extreme, it will lead us to something which is Kingsman movie, where you have that collaborative meeting. You are sitting in a chair and table, and around table you see other people. So one of the problems that we have there is, well, of course, first of all, controlling that avatar remotely and do it, but also is thinking of possibly heterogeneous physical spaces in a single mixed reality environment, and trying to actually provide the same content orientation. So, but that again, that's the story for some other presentation. So, what we had at, well, can it be done? And we had, so this is again very simple example how you can actually control avatar. And we collaborate with Virginia Military Institute, and we were able to do it in almost real time. What almost means 250 milliseconds. People were able to kind of quote unquote, virtually shake hands between Blacksburg and Lexington there. So with this type of application, and the problem is not so much about bandwidth, because really you can make very efficient protocol, something like MQTT or other lightweight protocols, and therefore latency is really what's critical. If you have low latency, let's say between Blacksburg and Lexington, it was, I think we measured it under 50 milliseconds using just sending packets, and then with overhead of processing that in your app, you can still stay around 250 milliseconds. Ideally, you would like kind of 150 milliseconds, which is your human in the loop goal, but there are places for improvement there. So that actually brings us to, and I guess just a reminder of that reality virtuality continuum, that we can actually see that on one hand we have our physical world, that a real environment. On the other end, we have that virtual environment. And really what we are trying to do here is how to bring those two things together. And you can now imagine that being the challenge is being multiplied by several physical locations. So if you look at the year of publication, 1994, obviously collaborative virtual reality, distributed virtual reality, a lot of work being done, telepresence, telerobotics, but it is always was the problem that infrastructure devices that you need to use, something that really you cannot effectively apply for education on large scale. So let's see how we can bridge together real and physical world. So going back to our original challenge, original motivational example, which is experiential learning, skill development, vocational training, nursing is a rather good example. So we collaborated with Abingdon, Virginia High School and their nursing program. And there is that Convert Virginia 21 skills that they need to learn. And in order to learn them, you need to go to nursing lab, you need to, which is in essence a hospital room with beds, mannequins and all that stuff. And you need to practice for training. So is there a way that we can actually bring that hospital room or nursing training facility, if you want to call it that way, to regular classroom? And so now we have that, how to put it, we create a computer or virtual model of that hospital bed and the nursing lab, and we want to superimpose it to a regular physical place of a classroom. So for that, what we need to do, we need to have spatial mapping. In other words, we need to be able to track the human body using a device such as Kinect. That's old Kinect. Kinect Azure is actually much better. And there are other technologies that can be done, that can do it actually rather fast. The only downside is that it used to require a really good graphic card. When I said used to require, it used to require GeForce 970. Now with 3000 RTX 3000 series, it's so much better. We tried with 3080, so we tried with 3090, and it's getting really, really good. So anyway, so what happens then is now you can see superimposed, of course, slightly different perspective, superimposed computer-generated object or artifacts within real world. So let's see how that works and how would such application for experiential learning work.
Select skill. Next skill. Previous skill. Start.
Step 1. Put on clean gloves before handling denture.
So now we have that
Next.
Hospital room.
Step
We have
1A. Get clean
very
gloves from the
structured
glove
set of
box.
sets, audio and textual information. So now student needs to mimic physically, all these things they need to do. And by
Step
tracking,
2.
we can really
Bottom of
provide them
sink
body
is lined
interaction.
or sink is partially filled with water before denture is held over sink. Step 2A. Plug the sink.
So again, just by tracking body, we can
turn the faucet on
create
to
that.
fill the sink with water. Step 3, rinse the denture in moderate temperature running water before brushing them. Step 3A, pick up the denture. Step 3B, rinse the denture with streaming water.
And of course, you can notice a little bit a lag, and
Step 3C,
because
put
again,
the denture
Connect
back
2
on
does
the
not have really
Step
good
4,
understanding
apply
or
toothpaste
good
to
tracking of
toothbrush.
hand or finger
Next.
joint. But
Step 4A,
there are ways
pick
to
up
actually
the toothbrush.
create multi-level or hybrid
Step
tracking
4B,
system to
pick up the
improve it. That the
toothpaste.
problem is that
Step
then
4C,
significantly
apply
reduces
toothpaste to
the
the
space
toothbrush.
of embodied
Step
interactions.
4D, put the toothpaste back into the base. Step 5, brush surfaces of the denture.
And we tested that, and I think the good
Next.
thing is that now, if you have some
Step 5A,
teachers who are
pick up.
familiar
Step
with some
5B,
basic
move the
technology,
denture above
we
the
actually
sink.
actually
Step
no, they have their
5C,
own
brush the
HoloLens
surface of
devices,
denture.
and they actually conducted user study for us that was published, and we published paper at Kelvar workshop at IEEE
Step 5D,
with
put
school
the
teachers as
toothbrush on the
co-authors.
paper towel.
So anyway, it was a little bit longer segment, but just to give you idea what ideally should happen for student to see. But now the question is, okay, that's fine, we can deploy it, and student can practice their own, but still there is no, a teacher is not present. So now what we want to do is actually move it to the other end and help teacher be able to do similar thing. But before that, another example, which is again step closer toward supporting distance collaboration. So this was done to look at how we can actually provide the poster exhibition. So I had a group of students, some of them from College of Architecture, and they often, have the poster on the walls and trying to present the work. So we tried to figure out, can we actually do something like that using mixed reality? So again, let's just first take a look at that.
Museum.
So idea is they, detect based on geometry, detect vertical surfaces of place. We can actually place that ion, select individual
Studio.
posters, and it is not just putting them on the wall, which you have seen, but also to get corresponding 3D model, explore them, evaluate them, and you can imagine that happening in real time. All the students in their respective homes exploring individual posters. Or, as we are going to see shortly, you can actually have all posters. So now they are appearing on the walls, and again, you can walk and take a look at that. So now again, teacher can be more active here, walk from poster to poster, and do it. If you look at some of the conferences, what they do usually with conferences, like I mentioned, example with Mozilla Hubs and with Virbela, is they put them on the geometry. So it's I don't know how to put it, because I had a poster in a IEEE in Mozilla Hub, and people just don't come. I mean, they are, yeah, okay, whatever. I mean, what's a really big deal to talk to someone, and I may as well go and look at that separately. So at least that kind of interactivity was fairly limited. So again, I'm trying to point out that this may look quote unquote cool, or at least for the first couple of times, but it is really not quite effective. So what we're trying to do is next, and let's look at this, is to provide, this is, if you haven't ever been to Northern Virginia Center, so this is a map of a classroom in Northern Virginia Center. So we try to do is to say, okay, first of all, how to allow user to easily configure. So therefore, you can just specify general layout, and you can create the different spaces. Something that's in essence editing a configuration file. You can even use the text editor to change those setups. Let's see. I should probably do a little bit better editing. So this is, let's say you can have a setup with the meeting room. Let's see. Just be patient a little bit. For my next presentation, I'm going to try to cut those segments. So in terms of the classroom, what we would like to be able to do, again, to try to provide some better interactions. So post-COVID classroom, which has those tables further apart, and again, you have now the similar setup here. So what now we can do is how we can actually effectively integrate that using now new Kinect Azure. So you can see it actually works pretty well, and we can now track users and have them provide gesture for that, which is better than there. Similar for standing. Of course, choice of avatars can be questioned here, but it was just the cheapest one, or the cheap one, or not, I should say free of charge one that we were able to get. Oh yeah, I should have done better editing. So what is not shown here is the following. We can have that multiple collaborative, in other words, multiple users in that environment. Not only that, as you move in that environment, you can actually move furniture. So you can actually, just by moving your body, you can move tables, flip tables, and doing things like that. So again, when that happens, the table becomes red, and you can actually provide that interactivity in the virtual space by putting together several several physical spaces where teachers and students are. So what is the final goal here? So again, as I said, we started doing that during summer. Our goal is actually to focus on teacher. In other words, provide that capability to be able to fully track teacher as user performs experiments either in real and virtual setup, and then students can use some let's say cheaper platform, let's say even Chromebooks. We are trying to see with Price for Elementary School that garnered one of the not my student, but one of the students that collaborates with my student, I think so that's the way to put it, can then see whether or not those Chromebooks are actually capable of accessing that through WebGL. So therefore, the student can freely navigate in classroom without worrying about COVID or things like that. Look exactly what teacher is doing, and therefore be able to provide content. So the goal is to provide in that also, because it is web-enabled, we are simply deploying it as WebGL, something that can then be switched from that virtual reality version and make it mixed reality version, as we have seen with nursing aid. In other words, in your regular room or office, you can project the classroom, you can navigate, you can move around, you can even do some mapping between virtual world and physical world. So here are a couple of examples. Pokemon Go, which you all know, playing games and also using AR kit. For example, this is, I believe, iPad Pro, where you can project digital content on physical surface. One of the things that just came out maybe a couple of weeks ago is Mario Kart Live. I'm not sure how many of you have experienced that, but there is the following. You are going to have that small kart, which is, I think, I don't know, $100. So here you have, it has camera, it has everything based. So what you are doing is you are actually remotely controlling that kart, or we can call it robot. However, this is not your traditional control when you have telepresence and camera. What you actually have, and you can see here that you have your physical world, that's somebody's living room, and then here you have superimposed digitally constructed objects. So now this is the camera that is there. You can see what's going on as you fly. By looking at the wheels, you can also calculate speed. So it is actually rather amazing, and that's actually I kind of want to go on the tangent. Unlike, let's say, PlayStation consoles or Xbox console, Nintendo always went for for simplicity, but kind of what's called willing suspension of disbelief. So you can play tennis, you know, just remember that old Nintendo Wii. So I think I have like 5 seconds clip that just give you some idea of what's going on. So now you can, whole family can play and, you know, do racing in that. So now you can imagine how something like that, in connection with some better educational content, can really help with the education. So I am what? Ooh, okay, a little bit longer. Sorry, let me finish now promptly, so that not to test your patience. So what are some of the challenges? So again, this was 3 months a project during summer. We are continuing working that. We are working with Abingdon. We are working with Toronto Higher Education Center. We are working with Virginia Military Institute in Lexington, and we are trying to add a couple of more schools. And when I go to on a sabbatical in 2 more weeks, I will try actually do it. Yeah, don't hate me. For those of you who have to stay, I'll try to do the same thing. I'm going to Austria to VRV's Research Center there, and actually try to connect and establish connection also with VRV's. So what I plan to do then is so how to effectively test and deploy this system given the school closures. Just for illustration, we were planning to having that in Toronto Higher Education Center, but the last 2 or 3 weeks they have like 3 to 4 COVID cases when they had to clean the floor, etc. So it's kind of almost ironic that we are trying to do something to deal with school closures, and then we cannot do that because the center is closed. How to deal with low-end platforms? Again, going back to my original statement, it is teacher-centered. So teacher will have that high in the platform, and then making sure that students can work with that on even on the Chromebook platform. With that, then we can proceed to facilitate engagement with high school teachers and students. So hopefully next semester, we are going to use that for nursing and maybe for some other STEM labs, STEM topics in Abingdon. And certainly in Toronto Higher Education Center, provided we actually are able to go there and install infrastructure for smart immersive environment. And there is always opportunity to integrate existing applications or new applications that are there. So some of the opportunities that are already mentioned, this is the last slide. So collaboration with other universities, outreach to Virginia K-12 schools, so industry involvement. So we have collaboration with 2 startup companies, and we are trying to, to expand on that. There are also various foundations that help with that. And I think it's also interesting, and I would kind of use this opportunity to do a little bit of propaganda. I think this can be actually a good topic that we can perhaps find some common interest and integrate or use related research efforts. If we have something that is in VR or in mixed reality and that you think that's for education, perhaps we can put it in our platform and make it available to teachers. And if you're on the business side, you're looking for money, here is the money proposition. Right now that XR in immersive learning technology is what, 1 billion. It's going to be between 2 to 10 billions by 2026. So there are also opportunities there for entrepreneurship and starting your own company. So with that, thank you very much for your patience. I think I went a little bit longer than planned, but hopefully not too long.